Good
morning,
Keep
everybody.
your video on, sir. Keep your video on so
Yes,
that everybody can see you.
Okay. Good morning, everybody. It gives me immense pleasure to welcome our eminent speaker, Mr. Tushar Bhaskarwar. He is a research scholar at SGG, Sri Guru Gobind Singh College of Engineering, Nanded. And today he is going to deliver his expertise talk on automation, IoT, PLC, and MATLAB. Before introducing our chief guest, I will brief introduce about our institute. So our institute, Sri Vitthal Education Research Institute, College of Engineering, Pandharpur, located at an holiest space of Vitthal Rukumai in district Solapur. So we are having 5 branches: electronics and telecommunication, mechanical, civil, computer science, and electrical branch has been started in 2018. Since the institute is established in 1998, and previously we are having only 4 branches. All 4 branches are NBA accredited 2 times, and recently we have started our electrical branch in 2018. Since our electrical branch, which is started in 2018, it has been good academic exposure, because our first batch is going to pass out in 2021-22, and out of that 66 students, near about 35 to 40 students already placed in various organizations like Infosys, then Bharat Forge, and various other companies which are there. There are a number of companies in which the students are placed. So now I introduce our chief guest, Tushar Bhaskarwar. Sir, as having a past experience in various industry, basically IoT based, programmable logic controller and MATLAB programming, and he is pursuing his as a research scholar in very good institute, that is Sri Guru Gobind Singh College of Engineering, Nanded. And this is the brief introduction of our eminent person. His basic having an industrial experience of automation, as well as various companies he has already served. So with this brief introduction, I will give hand over the charge to our eminent speaker, Tushar Bhaskarwar. Sir.
Yes, sir. Thank you, sir.
Welcome Tushar from Swiss College of Engineering, Pandharpur.
Thank you so much, ma'am.
Okay, now he will make you host so that you can share your PPT and you can start your presentation.
Sir, I will make you host.
Yes, sir.
Sir, can you unmute yourself, Tushar, sir?
Yes, yes. Is it okay? Means, am I audible?
Yes, audible, sir.
So is it necessary to start my video? Because if I start, then it may possible that I will it will be less broad bandwidth to publish. So
first of all, we will make you as an host. Then you can share your whatever the contents are there. Okay.
Sir, already I make him host.
Okay.
Okay. Now you can off the screen, sir.
Yes, I can. Yes, sir. I can share my screen now. Is it? Yes. Just a minute, sir. So is it visible now?
Yes, sir, visible.
Okay, sir. So firstly, thanks to all the professors, ma'am, and all the students for inviting me in for this webinar in Swiss College of Engineering, Pandharpur. I heard about college, and I quite know that you are doing well in the research field as well. So it is my honor to serve as this webinar. From this webinar, I will going to deliver the kind of research is doing in the industry and what are the basic things we are using as a controller for industrial automations. So fine, I will start my session. Am I audible and screen is visible? Just confirming.
Yes, sir.
Yes,
Yes,
sir.
yes, your screen is visible, but you make full screen, Tushar.
Yes, yes.
You make it full screen.
Yes, okay.
Full screen,
Okay.
and if possible, make your video on. That will be better, so that one-to-one interaction, they feel that I actually we are meeting online, but if you make your video on, that will be much better.
Yes, ma'am. Actually, I will face with some kind of bandwidth issue. That's why I have not turned on my video. During some practical hands-on or during the hardware showing, then I will turn on my video and I will show the whatever the controllers I'm having. I will just give the brief introduction on that at that time. Is it okay?
Okay. You continue.
Yes.
Yeah.
Yes, ma'am. Thank you. So basically, in industrial automation, we are dealing with timers, counters, and maximum we are using with timer counters and the digital logics. Okay. So in digital logics, we normally used normally open contact, normally closed contact, and what they are that we will discuss in brief. So before that, we are going to discuss what is the introduction of this industrial automation from where it is started in industry, how to digitalize all this world, and how to make man works effort will be is less. Okay, so that we will discuss. So before starting that much means automation thing, we will start with introduction. Okay, so this automation means what is nothing but working make man's effort less without any doing of just by doing any kind of programming. We can automate anything which is situated much beyond our reach. Okay, so this is how we can automate. So that automation is belongs to software as well as the industrial level. Okay, in industry, what we can automate, like you know the field of power plants. Okay, in that power plants, if you have any kind of motors, that motors turn on and off positions or speeds, that speed control or position or whatever the on and off status, that we can control using the programming of this industrial controllers. So basically it starts from this, it just increases the productivity means and increase the robustness, because these controllers are very robust. If you put them into a very harsh environment like 60 degrees 70 degrees, then also it will be sustained. If you put it in a water as well, then also it will sustain, because the embedded technology in these controllers are very good. Okay, so this is why it is very robust. I think someone's mic is unmuted. Please mute it. And later, the human cost or human labor cost and expenses, it will reduce automatically if you use this automation. Okay, and it will increase the quality as well. Okay, so the history of automation from where it started, that we will discuss first. But first, we are going to discuss the manual control. Means before starting this automation, what the human doing, that they just doing the manual work, means just go there in a field and just turn on the timer for a few seconds, and then after that time it will turn on and off a particular device. Let us say what is the disadvantages of this manual control. Like if you know that humans are means, uh, likely humans are will make errors. Okay, but system will not, the software will not. Okay, if you program a controller or any software to do for some task, then it will do that things appropriately or exactly correct. But if you do a human kind of things in that, means if you do by its own, it may be chances of 80 to 90%, sorry, 10 to 20% of human errors. Okay, so that is why there are certain disadvantages. Then it is discovered by the pneumatic control in 1920. Okay, pneumatic control means what? Whatever the work we are doing with hand, that can be controlled by now a air. Okay, so this pneumatic control, hydraulic control, these kind of things also originate at that time. Okay, but the main disadvantage of this pneumatic control is what? The systems are very bulky and complex. Means to control certain control wall, or to turn on or turn off some things, we required air. So to maintain that air in certain compressor, the size of that compressor will be much higher. Okay, so you can understand. So this is how the system will becomes bulky and complex, and it is very hard to control that bulky system. So that is why you can see one example of a pneumatic valve as well. Okay, so here you can see here the I think all you know the relay. What is the relay? If you don't know, then I will just give a introduction on what is relay means. If you have a 24-volt DC supply, okay, and that DC supply is comes to the coil, okay, this is the coil, okay, this is the coil. If that DC supply comes to the coil, it will energize and it will turn on some relay logics, and it will switch the supply to the air pressure, and this air pressure is connected to the compressor. Okay, this is compressor, and this compressor will blow up the whatever the operation, like if you have to blow the balloon, then it will blow this balloon using this knob, correct? So this is how we can control the things using pneumatic way. Just give a 24 supply from here, it will just turn on the coil, and it will switch to a normally open supply and normally closed supply, and it will turn on the it will blow the air. Okay, so this is how it works. So this is the relay. This is the 24-volt supply. It comes to the relay. Okay, this is the relay, and it will blow the balloon for a certain time, and then it will turn off. Okay, so this is kind of bulky things. We need to handle much logics and systems. Okay, then it comes to the hardwired logic. Hardwired logic means, I will explain with graphical presentation. Means here, if you see, this is the contactor. Okay, this is the contactor. Contactors are the three coils, means three switches here, and to energize these three coils, okay, the RY big. So what we required here, three phase. What we required, we have to turn on the relay, this relay or this coil, okay, and that coil should be turned on after 10 seconds. So you require one timer here, okay, and this is situated in a field. Okay, this is situated in a field, and there is a timer knob. You can see here, there is a timer knob. That timer knob we can move, means 5 to 10 second, or whatever the second setting we can fix here, and we will send a power supply to this timer. Okay, and it will start to count that timer. After certain time, after 10 seconds, it will turn on the coil, and it will switch the supply to normally NO contact. Okay, in NO contact, okay, normally open contact, and it will, what it will does, it will turn on this contactor. This is, I think this is the ground, and this is the plus. So it will turn on this coil, and whatever the motors or whatever the pumps are connected to this phase will get activated. Are you getting? So this is how this wired logic works. Is it okay? I mean, if you take an example of your household boring or pump like devices, there are two buttons on and off. This is green and red. If you press a green, then it should start a motor, and if you press red, then it should stop the motor. And that all logic should done with a delay of 10 seconds. Okay, so that is my conditions. Okay, so when you press start, then what it will does, it will give a 10-second of delay, and after that delay, it will give it will give a 24 volt supply to this contactor, and whatever the devices connected to the contactor will get turned on. Is it okay? Now then, if you press stop, so same thing will happen here. If you press stop, then what will happen? It will again turn on for after a 10-second of delay. That kind of logic we can make here. So this is how it works. The main thing is that this is how we can design a hardwired logic for this application. Okay, but what is the disadvantage here? This is also bulky things. We need to handle so much of things. This means this kind of this hard timer. Then if and you all know that there may be having kind of mechanical things inside this. If it is fails or if it is not works, then you have to replace this, and it is very costly, and there are many wires as well here. Okay, so this is means this is the one kind of disadvantage. We need to handle it properly, and it is very complex wiring. Okay, and if any kind of error happens here, or we come across any kind of faulty things here, then it is very difficult to maintenance and troubleshooting. Okay, so these are the main disadvantage. So manual, pneumatic, hardwired logic. Okay, these are the main things, main disadvantage. So that is why we move towards electronic control. Okay, it is very time saving, energy saving, less maintenance, and they are more reliable. So that is why we are using electronic control, which is used in our computer softwares as well. Okay, so these are embedded logics, embedded used in embedded chips. Okay, and we are using this in current scenario. Electronic control logics means after there is advancement in that also, that we will discuss, but after this hardware logic, this comes. Okay, this in 1960 this comes, but there are certain disadvantages here also. Okay, so it's like it will take a more project time to maintain that logic gates or to wire this logic gates properly. So let's say you have a relay. I just said the working of relay here. Okay, so relay, what it does, see, this coil will energize with certain voltage, and it will turn on any contact, whatever the commons are connected with a power supply, plus minus, and it will blow up the bulb or any kind of applications, and then it will turn on this application. Okay, by using this loop. Fine. So similar work is what? Contactors. Just here there are three phases. Everything are remain same. Okay. So to remove the disadvantage of electronic gates, we comes with a programmable logic controllers. So these are nothing but a PLC. Okay. And inside the PLC, I will show the diagram and architecture of PLC as well. So inside this PLC, we have microprocessors. So I hope all you know what is microprocessor. It will use to work various applications just by programming by some logics or some programming language like C++ or Python or ladder logics, whatever the logics, as per that device manufacturer design. Okay, so using that logic, you can program these microprocessors. chips. Fine. So this PLC is invented in 1970s, and till now we are widely used this PLC in industry. Okay. So you can see here that it can be effectively used in application ranging from simple control like replacing small number of relays to a complex automation problems, like in the robotics industry, or in design of, or in the field of automobiles, you need to design or you need to manufacture many cars at a time. So to handle these cars, robots are there. Okay, and that robot control can be also programmed using a controller, and that controller is a PLC. Are you getting? So this is how we can control the PLC in many way in many industries. Depend on which industry you are working. Like if you are working in process industry, or automation, automobile industry, or pharmaceutical industry, everywhere this PLC are used widely. Depends on their applications. So in process industry, like if you take example of controlling level of any tank, in automobile industry, you have to control the robotic hand. Okay, you have to move the robotic hand from some position to some another position. So for that we require certain delay of time. Using that delay, or for certain period of time, it should move, the motor should run. After that time it will turn off. So that is how we can design a logic inside PLC. But here you must be know that one thing you should remember, that in a process industry we are using PLC widely for digital applications, like just on and off of certain motors and valves. Okay, but in robotics industry we are using PLC widely for analog purpose. Okay, analog purpose means the continuously we have to change the data, or we have to give the set points. Okay, just like controlling a speed, it is an analog quantity. Are you getting? So this is how we can use the PLC on in a many industries. Fine. So what it will do, it will reduce the space. Okay, so whatever the space required for this timer. Okay, just I have said this timer. So this timer space can be reduced, and these wires are also means reduced. Space of wires also get reduced, as well cost also, using this PLC, because we can make a logic of timer, okay, inside PLC only. Fine. And if any problems occur, then also it will easy to maintain, means just by checking or looking the program where the problem we are facing, we can troubleshoot that problem, or we can even change the problem timers setting. Okay, if you have to change the timer setting, what do you need to do here in the wired logic? You first have to go to the field, okay, where it is situated. Just then look for the which kind of contactor we are getting a problem, we are giving the problem. Then go there and just then change the knob for some setting. Come back to your place of controlling. Then check the is it working or not. So it will take lots of time. So here in PLC, just by setting your place, you can change the timer, and you can simulate the logic, and you can check is it your application working properly or not. Okay, so these are the advantages of this PLC, and it is more reliable. Okay, and whatever the time required for our project will also be lesser. Fine. So there are main components in industrial automation, means steps how we move forward to automate any kind of project. Okay, so there are certain steps. So first step is field instruments, or like these things. I'm showing it in a block, a red mark. Okay, so these are the field instruments. Field instruments means what? So like sensors and transducers are the field instruments which can sense the physical quantity from the environment. Let's say if you have to measure the speed of certain motor, then you might use that sensors. Okay, I just you can use the aerometer. Okay, so that meter which sends the lasers to the motor speed, and it will count the motor speeds, and it will send that analog data to your means control panels. Okay, so this is how you can measure. Just like temperature, if you have to measure temperature, then you have to use sensors only. Correct. So these sensors will give the data by field cabling to the junction boxes. So junction boxes means what? Where all the wires are connected on one platform, just like your uh, household board of electric board. Okay, there we are getting buttons here. Okay, so just I'm giving an analogy here. It is not like that, but you can consider that that is a junction box where all the wires comes at one place, and from that place it will combine in a one cable, and from that cable it will send back to the control panel or a control room. Specifically we can say, so control room, this is like a control room. You can see there are multiple operators seated in a control room in any anywhere you have seen, like, and they just see the screens, very big screens they see here, and from that screen they just monitor the physical quantity which is sent by these sensors on their screen. Okay, they monitor this, and just by typing certain programs here, okay, just by sitting here and typing certain programs or control setting, they change that physical setting so that it should not give any kind of error, or it should run properly. Okay, so this is like a control room. This is the work of control room. Okay, operators, the operators doing these things. Okay, fine. And also control room also having a hardware, means whatever the, like this you can see, this is the controllers, whatever the cables, whatever the cables going from the field, these fields cable are uh, connected to the controllers. Okay, these are the controllers, and from that controllers we operator are monitoring on the screen. This is the screens. Okay, they are operating what is going on in a field. Okay, and these things, these monitoring things is known as HMI. Okay, this is called as PC or HMI, whatever it may you call. This is a SCADA. So this is the basically 3 steps of any automation cycle. Okay, means field, sensors, then it comes to the control panel or control hardware in a bunch of cable. Okay, and then it will check or monitor the data on a screen. Okay, that screen is like, say, you can say it as a human machine interface. Okay, or a SCADA softwares are there. SCADA software means supervisory control and data acquisitions. So you can supervise all the control as well as you can acquire the data or log the data or save the data inside one software. Okay, and these are the screens they are watching on the monitors. Okay, in front of them. Okay, and so many functions like what is the level of the certain tanks, what is the speed of motor. Okay, so they just monitoring all these things. on their screens. Okay, so it seems to be very good, means how this automation cycle is going on step by step. It is moved by these steps. Okay, but in advanced technology, what happens is that there are instead of this junction boxes, okay, this is the very traditional kind of thing, junction boxes. uh, bunch of means wires comes on these junction boxes, and that's why if any kind of error happen or problem occurred, then it is very difficult to troubleshoot the problems from, because lakhs of or thousands of wires comes on these junction boxes, correct? So which wire goes to which device? Okay, that is kind of mm, tough task. Okay, so to handle these things, in a recent technology, it comes across a field bus cabinet. So field bus cabinet means what? Field bus cabinet means it is same like junction boxes, but they are smart now. These field bus cabinets are smart because they, without any searching efforts by human, they they only tells the where these problems occur and which device the problems is occurred. Okay, so these are smart field bus cabinets. We can also say it like a field bus network. So these are the smart uh, devices, you can say, and remaining all part are same. Okay, control hardware is same, SCADA is also same. Some advancement is there, but the structure is same. Only the field buses is the advancement in the in system uh, in case of junction box. Okay, I hope you all understood this. Fine. So just we will move towards what is sensors, transducers, and later we will see the programs on software as well. Fine. So what is sensors? As we have discussed, that it will sense the change in physical parameter like temperature level, pressure, humidity, and many others. And what it will does, transducer, what it will do, it will convert the electrical means it will convert non-electrical to electrical signal, because sensors is like just a temperature, means sensing. But if you convert this temperature into a readable format or electrical format, okay, so this is quite good, means we can send this electrical signals to the controller, and controller will calibrate that signal in certain form, and it will show us how much of temperature or how much of level is there. Okay, it will give us a quantity in certain kind of readable format for us. Okay, so there are certain signals like RTDs or thermocouples which measure temperature. Fine, and these are the standard signals we have to maintain for sending data or for sending us electrical signal, 4 to 20 milliampere or 0 to 10 volt. Okay, these are the standards designed by the industry, which we have to maintain, 1 to 10 volt. Okay, this is 1 to 10 volt, and this is 4 to 20 milliampere. This is in voltage and this is in current, 4 to 20 milliampere. So why 4 to 20, why 1 to 10 volt only? So this is very big portion of, means big concept, so that we will discuss if we possible. Fine. Just you need to remember only 4 to 20 and 1 to 20, 10 volt as of now. Okay. And these are some field instruments like flow transmitter. Inside flow transmitter, we are using electromagnetic flow transmitter, pressures. There are certain transmitters. Fine. And these are the manufacturing companies of field instruments. Okay, like Anderson Hauser, Honeywell, ABB, Yokogawa. Okay, and now we just conclude with one kind of outline here. Okay, that how the control is done inside inside one application. Okay, like you have to control the let's say here what I means temperature is we have to control. Okay, so temperature is control. Then first there may be a process. Okay, so this is the process. So to control the temperature of this water. Okay, so this temperature is first sensed. This temperature is first sensed using some sensor. That sensor is will give the feedback to the controller. I hope all you know the feedback control system subject. In that subject also you must come across the negative feedback, positive feedback, that kind of thing. So same thing we are seeing here. Okay, so there is a feedback, and this feedback must be a negative, and there is a set point. Okay, instead of step you are giving in the that feedback control system, we are giving here a set point, and this set point might be analog or a static. Okay, fine. So this will generate one kind of error. Okay, and this error will goes to the controller. So this controller is nothing but a whatever algorithm we have designed to control our final reach or set point. Okay, so that it will take care of that, and it will generate one kind of output, and that output goes to the final control element to maintain the flow of steam inside this process. Okay, so if the temperature is less, okay, if the temperature is less, then it will generate a kind of output, so that it will send a more steam to the process, and this process will act like increase in temperature, and if it is hot, then it will sense again, and it will try to minimize the error, and it will try to minimize the error, and it should be equals to 0. That is how the control is done. Okay, the same structure is doing in the industry as well. Okay, so this is how we are controlling the things in a field. But in field there are many control hardwares to control this whole process. There are PID controllers, there are programmable logic controllers we have seen, and there are DCS. So DCS is the most advanced thing in the industrial automation. In the last few hours or few minutes, we will try to summarize what is architecture of distributed control system and how it works this year. Okay, fine. So what is the working of PID then? So just you have seen here this algorithm. What this algorithm is, this is like a PID. This is like a PID. Everything, if you have to control you have to control a flight of aircraft, then also you require a PID, because PID is used everywhere in industry. If you have to control a level of any tank, you have to control a robots to maintain the position of certain parameter, or if you have to control the mixture of two reactions liquids in pharmaceutical countries, companies, or in automobile as well. Everywhere you require this PID controller. So this is a stand-alone controller PID, which takes a error, which allows us to give a set point, will generate error, and try to minimize that error using certain control actions. So this is just a basic skit which shows the tank level control. There is one PID. Uh, we are giving a setup set point to this PID manually, and it will sense a data of what is the level using this pressure differential pressure transmitter. It will send the data back to the PID. It will generate error. If it is less than a set point, it will increase the pump speed and it will maintain the set point. It's a 50% set point. Okay, it will try to pour more water inside this tank. Okay, and it will try to reduce that error to 0. This is how this standalone PLC works. Okay, but what if we have many process like this? Then we can use like in many PIDs, standalone PIDs. Okay. Okay. So this is how we can connect our PIDs to various applications. Fine. But it is very difficult to monitor all at a time. Okay. So that is why what we did here, you can connect all these PIDs in to the serial connector RS2322485, and it will send a data to the PC, so that it will send a data once at a time to the PC, and we can monitor all the parameters inside these PIDs. Okay, so this is how this standalone PID controllers works. Okay, and these are some brands of manufacturer PID controllers. Okay, but we are discussing what we are discussing PLC. What is the advance or what is the need of this PLC? Here you can see this is only you can say it is one kind of work can be done using this PID. One kind of work means what? Only they can control the analog parameters. If you have to control the valve of any certain process, if it is connected to a tank, then you have to control a valve, and that valve should be on and or else off. Correct. So it cannot work at that point because that is the digital work. Correct. So PID will not control at all time. Correct. So in such time, we require a controller which can do each and everything what we want. Okay, so PLC will gives us a liberty to do whatever we want to do. It can even control the analog process. It can even control the digital process. Whatever we want, we can do as per our applications requirement. Okay, so like you can see here, it is an industrial digital computer. Okay, which has been means it is very rugged. Rugged means what? It is sustained in very harsh environment. Okay, and adopted for the control of manufacturing process such as assembly lines or robotic devices or any activity require high reliability control. Okay, high reliability means you can trust 100% or 99%. You can trust them. Okay, and it is very very useful for diagnosing. If any fault occurs, you can diagnose or you can troubleshoot that problems easily. Okay, so this is just a thing that it is a hardware controller, and we can connect it to a various process. Now, so this is the main part of a PLC which we are starting here. Architecture of this PLC. So you can also take a screenshot of this as well if you require. And you can see here, so this PLC is having a processor. Okay, so this processor is like a microprocessor. Okay, microprocessor you might seen in your second year or third year, I don't know. So this is like a microprocessor, and we can program this microprocessor, and it will generate output depends on certain inputs. Okay, and inputs are like sensors. Okay, push buttons or switches, just on and off, or level limit. Okay, so if the tank level reaches at the top level, you can put sensors like switches, limit switches, pressure switches, just like our pressure cooker is having a switch, limit switch is there. If it is above certain pressure, then it will just try to remove from the cooker pressure. Okay, so there is a limit switch there. If it is not reached, if it is not working properly, that switch, then it will release through the other weight. That is the limit switch. That is safety limit switch. That kind of switches is there for this input module. Why I'm giving you the household applications, because you aware with that. If you consider the industrial switches, then it is like hazardous switches. Means if certain problems occurs, there is a very buttons like red buttons. Okay, so that alarm buttons, these are like inputs to the PLCs. Or you can also see like a flow switches, means if it is giving a flow of certain uh, meter per second or not. Okay, so that is how we can give a input. So these inputs may be analog, may be digital. So push buttons are a kind of digital ones. Okay, so push buttons and limit switch, yes. So push buttons are like, if you press at certain time, it will press for that particular time only. If you release it, then it will give you a status of 0, just like motor turn on and off. Is it okay? So that turn on and off of motor is like a push buttons. You just pushing, and for that particular period only it will giving a input. So there are multiple inputs, like, fine, and it will give data to it will give a signal to the processor input module. Okay, and then whatever the control action needs to be taken, it will decide by the processor, and it will send that to the respective output module. There are multiple outputs connected to the output. Okay, out of that it will decide to whom it is he has to send a signal. Okay, now to power all this thing, there is a power supply. We can power input as well, we can power output as well. Okay, some PLC only give a power to the processor. Whatever the input and output power we require, we have to give from the outside. Okay, in some PLC only. Okay, here what we are giving a power to the whole architecture, assuming. So now this processor can be programmed using this programming devices. So programming devices may be your personal computer. So inside that personal computer, uh, we will have software to program this processor. Okay, so this is the main architecture of a PLC. Fine. So let's see the architecture of a Delta PLC. Okay, so this is just like I said here. This is the first one is middle one part, that is the its processor. There is a chip inside this. Okay, there is chip inside this which control all these things, and there are the inputs. Inputs are connected to the field, and there are the outputs. These are also connected to the field, and all this connected in a bunch of wires. Fine. And then there are the A to D converters or D to A converters. If your data is analog, then might be you need to control it to the digital, and if it is a digital one, then you have to control it to analog ones. Okay. Why we require this thing? Because see, sometimes your controller is not like a digital, means on and off only. Your controller is like pressure control wall, and in that place you require a 4 to 20 milliamp of current. Okay, 4 to 20 milliampere of current. So this currents we have to varies from 4 to 20, and this is analog signal. Okay, this is analog signal. But in case of digital, either it may be on or off, means 24 volt or 0 volt. This is the only thing. Is it okay? So both type of signals we have to handle in this PLC. Okay. Now there is a one programming cable here. This programming cable is connected to your PC, this PC, and that programming cable, using this programming cable, we can program this PLC. Okay. Next, let's say the Allen Bradley, which is very useful and very widely used in the industry. Allen Bradley PLC. Okay, the same structure. If you understand the first one, means what is the working of first PLC, it is same everywhere. Everywhere you might say the same structure of PLC. The first one is the processor. This is the processor. Okay, and inside this processor there is a CPU or whatever all the things is there, and upper one part is inputs. These are the inputs, input terminals, you can see. Okay, and lower one part, this part is the outputs. You can see here, these are the outputs. Okay, lower one parts, what are the terminals at the lower side, these are the outputs, and these are the inputs upper side. Okay, and there are screws to connect your motors or whatever the applications you, as per application you might having any devices. So that connections can be done with this screws. Okay, so I hope you understood this CPU part, input part, then output parts, and most important is wiring cable. Okay, these are the things. So using this programming cable, you can control or you can program this PLC. And there are certain LEDs, may some PLCs is have or something, some PLCs don't have, depend on which PLC you are purchasing. So this is Allen Bradley PLC. We show the power, is it working or not. So it is green or red power, and then it is running or offline mode. If it is running, then it will show the green signal. Okay, and you cannot download the programs, new programs, or you cannot reconfigure the program in the running mode in some PLCs. You have to go to the offline, just like I think you might have worked on Arduino. So in Arduino, you have to upload the program first, and then it will work like whatever the program you have done. Correct. So in PLC also the same thing, means we have to download the program inside PLC and it will run as per our application program. Okay. And if any fault occurs means what? Uh, fault occurs means, let's say, if your analog signal goes beyond certain limit means only 4 to 20 milliampere is required. Correct. So if you are giving us a 21 milliampere, then it might show you the fault condition. If cable is not connected, then it might show you a fault condition. Correct or not? So these are the certain LEDs shows on a PLC. Okay, to aware you that your PLC is having certain problems, you should go offline and try to solve this problem. Okay, and there is a force inputs. Okay, these are the basic things which anybody can ask, that what are the basic things about about PLC. So force input is one of the point in that thing. Force input means what? Let's say, just assume that you have a field layer. Okay, you have a field layer, and this is your baseline. Okay, you have here, okay, on the ground, and your output device is connected on the top. Okay, let's say this is the bulb. Okay, let's say this is the bulb, and as per the application, whatever the input connected to this bulb is also connected here. Okay, is also connected here. Fine. So all the time, if you have to check or simulate, is this bulb is working or not? All the time, what you require, you have to climb up to certain up position. Okay, and then just a minute. You have to climb to certain here. Okay, and then what you have to do, you have to turn on this input and you have to check, is this bulb is working or not, every time during simulations. In industry, there may be having various input located at various other points which we cannot go there physically. Okay, so during that time we are using this force inputs. Okay, so force input means what? Force input means what? We are just forcing from the program, from the software, that is it working or not. Without any input condition, we are forcing that input to turn on or off. And we are just checking that input is working properly or not. Are you getting? So during the forcing conditions, this force input are turned on. Means the LEDs of this force is turned on. Forcefully you are turning. It is not turned on conditionally. You are forcing to turn on that thing. So I hope you all understood what I'm trying to say here. So these are the some LEDs situated on a PLC, and there are status of input, means there are certain LEDs. That LEDs shows is my first number of input is on or off, second number of input is on or off. So these are the LEDs. Okay, fine. And similarly, we also have a status of output. Is my first output is on or off. Okay, so we can check using this status on a PLC. We can also monitor it on a PLC screen, monitor screen, PC. But except that, we can also monitor the inputs and outputs on a PLC here. Okay. So this is what Allen Bradley PLC. Related by it is not fine. So this is what we have seen as like Allen Bradley PLC. Then there is a Siemens PLC. Okay, so this is Siemens. So whatever the most profitable companies, you may say that Siemens, then Allen Bradley, Yokogawa, Honeywell, all these manufacture these PLCs. Okay, so this is Siemens PLC. The same structure as like we have discussed. There is a input, there is output. Certain change is there, but architecture is very same. Then programming cable. Okay, same thing. Same thing you can see here. So also there is a Schneider Electric PLC, like Zelio PLC. You might see on a screen. I can show it using my video as well. I will try to show that PLC. So first, before seeing, you can observe here. So this is the power supply. Okay, this is plus minus. How this PLC looks. It is very small device, but can control multiple 1,000 of devices. Okay, just by the small devices, we can control various devices. Okay, so this is the power supply of this PLC. Okay, then these are the inputs. Just like we have seen, these are the inputs. Some inputs are digital, some inputs are analog. Okay, this is the screen. Now, what is different in this PLC is it is also showing you the program inside the PLC. Means it is like advanced one. So it is showing you the program, how the program is giving you the output. So these are the ladder logics which is programmed inside this PLC. Okay, so this is programming screen. You cannot see these kind of things in other PLCs. Some PLCs offer this also. And you can also program this PLC using these buttons. Okay, these buttons offers you to program like what you want. If you don't have a PC, then what you will do? You go to the field, correct? And you have to program, you have to change some programs. Okay, you don't have a laptop, you don't have a computer, then what you do? So you can also program this PLC using these buttons provision for programming. And there are certain outputs like we have seen. And if you have a PC or laptop, then it is well and good. You can just take out this programming cable slot. There is a slot here, and you can connect that programming cable wire to this PLC and change the program. Okay. Yes. Anyone has doubt? Okay. Fine. So I can show that PLC. I will try to show. Is it visible, sir?
Yes, sir, visible.
Okay.
But
Yes, there is a issue of light. Yes, I can understand.
so can you put in a full screen mode of your camera?
Is it not full screen?
Sir, you should stop this screen.
No,
They-
sir. If students will pin that person, no, they can see automatically. Tell everybody to pin his name, Tushar's name.
Okay.
Okay, so everybody can pin this video of mine so that you can see the big screen. What I'm trying to see. So this you can see, and this is the power supply. So you can see this. These two pins are of power supply. Okay, so you can give a 24-volt DC power supply from generator. Okay, any kind of process power generator. Then there are inputs. Okay, these are the inputs. Some are the analog, some are the digital. Okay, and here they given provision for connecting wires of your inputs. Is it okay? So just you have to wire with these two cables and the work will be done. And this is the screen. Okay, this is the screen of your PLC. Now it is not working since it is off because I have not powered this. And these are the buttons. Okay, these are the buttons which can be used for programming this PC. And if you can take this notch, okay, you take this notch outside, you can even control or you can even program the PLC using some programming cable. Okay, and on the bottom side, you have the outputs. Okay, so these are the relay type of outputs and you can wire it as well, like here. Okay, so these are the wires. Can connect the wires here and can control your applications. Is it okay? Am I clear? Is
Yes, sir. Yes, sir. It
clear?
is very clear. No problem.
Mhm. So this is how you can control your multiple applications. Okay, using this PLC. So this is one PLC I'm having, Schneider Electric PLC. So using this PLC, you can control your application. Lots of applications like 1,000 and multiple lakhs of inputs, outputs you can connect, but only few inputs you have ability to provided by this PLC. Okay, so there are multiple other PLCs as well. That PLC will having a extension slot. So you can see there is a connections of mount cable. Okay, so just side to that there may be having a extension slot which can use for increasing number of input outputs to this PLC. You can even increase it to 1,000 of inputs. Okay, so this is how this PLC works. Fine. So I will stop my video. If you might having any kind of doubts, then I will try to solve this using turning on my video. Okay. Just for a moment, I am stopping video and try to move forward with the other slides. Okay. Fine. So just we have completed means PLC architecture and how this PLC look like and how we can control the applications using PLC and programming. Only the part of programming is remaining. That is also very easy, that we will discuss in a moment. Okay, so distribution of IOs through controller. So let's say just we have discussed the PLC. Now if you consider this, I just explained you how we can extend our IOs, multiple IOs. So same thing they have shown here in the pictorial format, that we can, let's say this is your PLC. Okay, this is only your PLC. Now if you want to connect more 100 of devices or sensors, transistors, where you connect? So there are extensions of inputs. So there are modules. So you can even connect modules to this PLC. So the type on connecting modules, there might be having two types of PLCs. One is modular and one is fixed. Fixed means what? We can only connect limited IOs. Okay, limited IOs we can connect. But in modular, we can do multiple IOs. Okay, multiple IOs till 1,000 or lakh. You can say you can even control one industry using 2 or 3 PLCs. Like this is how it is. It's very useful device. Okay, fine. So fine. So now we will just move to the little bit advanced one than PLC. So this is the DCA. So one thing is important to understand, that DCS is a very big, means it is just a controller like PLC, but it can handle a whole industry, one industry. Just like you have say a sugar factory. Okay, in sugar factory you required a number of input and output up to, let's say, 50,000 of inputs and outputs both. Okay, so that 50,000 inputs and outputs can be controlled using one DCS. Okay, you don't require any other kind of controlling device. Okay, and even you can monitor what is going on various stations or various fields. You can also monitor that things using a graphical way or graphical represented way. Okay, so that graphics can be made using SCADA, supervisory controller and data acquisition. So that is SCADA. So this DCS is inbuilt SCADA facility. So the structure is quite same like our PLC only. There is certain difference here. So let's say this is the field control station. Okay, field control station means one FCS. So FCS is having one controller. Okay, this is the controller. Okay, and that controller having a multiple of modules. These are the modules. These modules is connected to the various devices. Correct? These are the devices, sensors, transducers, wireless transducers, applications, whatever it may be. So these are connected to the modules, and there is one wire or control network is connected to your human interface station. Okay, means operator. Same structure is there of automation, but it is in very huge. You can say it is very vast. You cannot imagine one industry having how many of input. That many of inputs you can monitor with only one DCS. It means you can consider that how this works, what is the memory of this thing, because PLC are having very limited memory. This is a little bit larger memory, so that it can control so many devices at a time. Okay, and power distribution, how to distribute the power. Even in power distribution, company, you also might say the monitors on the screens. Okay, so that is also controlled by a controller, that is PLC or DCS, nothing else. Okay, because in industry only this works. No microprocessor, no Arduino, no nothing, no computers, only discrete or digital controllers, industrial controllers, which works, that is this PLC or a DCS. It may be having of any other make, like in our mostly India purchasing the Honeywell or whatever the Allen Bradley's, okay, or Siemens. But in Middle East, they purchase the Yokogawa, okay. It differs, but maximum we are controlling whole plant using DCS. So it may be having other safety control station. Means field control station is the one part, but safety control station is also there. Means what happens if some problem comes, like controlling 50,000 input output is not a, I mean, not a simple task. 50,000 input output is very big. So you might require a safety control station, which can which is having decision ability to take action, to take proper action. What if we get we come across some problems? Okay, so that logics we have to build earlier inside this safety control station. Okay, so this is very big. The architecture of this is very big, but simply it look like this. Okay, and the control panel of this DCS is like this. Now you can see here. I will try to simplify the this. So this is the processor of DCS, and these are the PLCs. PLC, sorry. These are the controllers, not PLC. These are the controllers. These are the processor. Okay, and these are the modules. From this point, it is started to connect modules, and on these modules, you can see there are a bunch of cables from a field. Okay, so this bunch of cables comes in a compact wire, so that it should not go anywhere. Are you getting? So it should be compact. Okay, that is why we require, because 50,000 of input outputs, how can you manage if it is very big bunch of wires? So that it is compact in a very small wire, and then it is connected to this module. Okay, and these are the expansions. In future, if you require any other, then you can reuse this. Okay, fine. So let's say your requirement is of 1000. Like as of now, your requirement of IOs is of 1000. That can be fulfilled using this rack. Okay, this rack is good for fulfilling your requirement of 1000 IOs. But what happens if you have to increase your input outputs to 10,000? Then you require another rack, so that it should fulfill our application requirement, so that it can controller can control the another 9,000 of IOs. So that we have connected the another rack below that. Okay, so this is the rack. This one is the rack below to upper one. And here also we are doing the same thing. We are connecting the number of IOs, input output modules. Okay, so these modules is having a compact wire. These wires connected to the field sides. Okay, So I hope you understood the idea of how to connect these racks or DCS inside DCS. So here also you can say, so this cable, just you have seen this cable, yes. So this cable is coming from the back side. So this is the front side of DCS. There are front side and back side. Okay. We can also say it like front and rear. So this is the rear side. So on the rear side, you can see there this wire comes from the front side and connected to the one section here. And on this section, you can see here on this section, there are wires. These wires. There's many of wires coming from the field. These are the cable tray. From this cable tray, there is the wires coming from the field. Okay. So these wires. Okay. So these wires are coming from the field, and from that we are getting a signal in a one compact form, and this compact signal is going to the module, this module. Is it okay? So this is how it is goes, the signal in DCS. Okay, so same thing, if I'm considering this about just a minute. Okay, so sorry. So this is how you can control whole application using this DCS, and this is the architecture. This is how the flow comes from field to controller and controller to field, and these both are the bidirectional communication. Means field devices are connecting to the controller. They can talk to controller, and a controller connects back or talk backs to the field devices. Okay. So this is what a DCS work, and there are companies like Yokogawa, Honeywell, Immersion, which makes this DCS. Fine. Okay. Now you can see here there is another thing, that is hybrid DCS. So what hybrid DCS is? It is not any kind of means keyword of hybrid DCS in industry, but a DCS which is of very vast IOs, like 1 lakh or 50,000. But if you are working with only 1,000 to 10,000 of IOs, then you can call it is like a hybrid one, means medium size of DCS. Okay, it is not kind of any keywords of hybrid DCS, but some calls it like a hybrid DCS. Fine. So next part is next and most important part of the industry, that is protocols. Like in our whole day we are using that Wi-Fi. This is one kind of thing which is allowed to use internet. Through that internet we can access means whatever the things we have to access, we can use using the internet. Okay, so the way of communication between devices to devices or devices to the controller is defined using a definition, and that definition is known as a protocol. Using that protocol only, that two devices connect with or talk with each other, or controller to device can be communicate using this protocol. So multiple protocols are there in the industry. As per their manufacturer, they design their own protocol and they connect their devices as per their protocol softwares. Okay, so this is the LAN, or everybody knows like this. Then there is a Modbus serial communication protocol which we used in our daily application. Like serial communication means printer like of thing, printer which cable is connected to the PC, and through that cable a serial communication means one is giving command of request of doing something, and it will send back to the printer and gives a command of doing print. So this is how it connect or communicate internally using some bits. So this is what we call it as a protocol. So we have a number of IOs connected to the field, correct? So these valves and starters, that how they can communicate with HMI or controller. So that is uh, that can be used, that can be controlled using uh, some definitions of communications, like we are using here RS485 or control area network protocol. Okay, so this CAN is very important because it is, we can connect multiple devices on this cable, and this can talk with devices using two hardwire lines, and it will generate a signal like this if it is sending any kind of data. If it is not sending any kind of data, then it will remains is to 2.5 volt, otherwise it will send 3.5 volt. Okay, so likewise, and this is 0. Okay, so this is how they communicate. Okay. There are multiple ways. Someone designed their own protocol and they have decided to send only 1.5 volt, and you can free to do that, but it should be a standard one. Okay, it should be, are you getting? So this is how it works. Fine. Then there is a OLE for process, means OPC protocol. Then Profibus device, multiple protocols are there. Then FF Foundation Fieldbus. Correct. So these multiple protocols, many more except this. Okay, so not only this much. So this is how we control our devices using certain protocols which connected to the PLCs. Right. Now coming to the software part. Okay, we require the knowledge of certain languages. Okay, and that means PLC and DCS require a language of function block diagram or ladder. Mostly we use a ladder logic for PLC and function block diagram for DCS, or signal flow chart for DCS. Okay, so these are the main things. Most of the company requires the PLC program for ladder logic only. Okay, and in DCS companies like Honeywell or anyone else, Emerson, they required a programmer of doing functional block diagram of sequential flow chart. Sequential flow chart means like you have solved flow chart, means it start, then take step, then if it is a kind of conditions, then do the condition, then take a decision. If it is not, go there, go here, and then stop. This all this kind of thing. Same thing we are doing here in sequential flow chart, but certain way is changed. Means concept is same, but the way or representation is different. Okay, so this is how we use the sequential flow chart. FBD means the name itself telling you the how it is, how it will work. Functional block diagram means there are block diagram like let's say you have input one. Okay, let me write it properly. Let's say it is, let's say it is input one. and this is input 2, and you have to turn on output by AND logic or logic. So there may be having one library. From that library, you are taking the block of AND. Okay, so block of AND you are taking here, and after that it will generate a signal, one signal, and it will turn on the output depend on the input. If both are 1, okay, these are connected to this. Okay, if both are 1, then it will turn on the output 1. Very simple. So this is how you do functional block diagram. But remember that this is not simple as like look likes, because we have to handle multiple inputs conditions to the one AND block. Like if this is on and this is off for 5 seconds, then it will set 1 and it will turn on the 1. So there are multiple, means 10 for one application. You might have 5 to 10 conditions. So it requires a logic understanding for that, and then you have to develop this logic and you have to download the programs at the DCS. Is it okay? So now how the ladder logic was, why it is called as a ladder logic. So this is also same means terminology. We can say name it is calling here ladder because the programming is look like ladder, because there is a ladder of various lines. Okay, and there is a input on the input side and there is a output on the output side, and if this input condition will becomes true, okay, these lines are connected on a 2 vertical lines. That is why they are called as a ladder. Okay, the 2 connected on a vertical line, that is why we called as a ladder. And both condition, if this condition satisfied, then it will turn on this output, it will turn on this output or off the output, or it will control the actuator by controlling the valves by certain analog applications. Correct? So there are certain programs we can use here in the PLC as well. Okay, so this is how we work for PLC, ladder logic language. There are other languages as well, that is structured text and instruction list. So instruction list is like your microcontroller, which you might have learned in your second year or third year. Correct? And structured text is you have to define a message for particular things to happen, and then it is quite difficult, but these remaining languages are very easy to adapt by any operator. Okay, fine. So I think we should give a break of 10 minutes. Is it okay, ma'am? 10 to 15 minutes. We will start at 12. Is it okay?
Okay, sir. Okay, no problem.
Yes, sir.
Viresh sir. Viresh sir, Patil sir, anybody is there? So Tushar sir, you are the host now. What we will do, we'll end the meeting and once again student will join with the same link, sir, at 12 PM exactly.
Okay, means we are break then I can
think
go.
let it
Yes,
be
yes.
there, sir. Sir, let it
What
be
is the
there.
problem?
Here. Ma'am,
Sir, want actually
I think-
Tushar sir want 10 minutes break actually.
Okay.
is it okay?
Okay. So, sir, we do one thing.
Yes.
Miss, whether we have to close the session or please off the recording, sir.